Welcome everybody, my name is Mr. Scott. I'll be helping you with graphing linear inequalities. To graph a linear inequality, we should follow these three steps. First, we should solve the inequality for y. Next, we should graph the boundary line y equals mx plus b. When graphing the boundary line, use these two rules. Use a dashed line for less than and greater than inequalities, and use a solid line for less than or equal to and greater than or equal to inequalities. Once we have the boundary line graphed, what we want to do is test a point not on the boundary line to determine whether to shade above or below the boundary line. So let's use this process and work through this example problem together. We want to graph the inequality 2x is greater than negative 3y plus 6. So you can see the inequality is not solved for y. That's our first step. To solve the inequality for y, we should add 3y to each side and subtract 2x from each side. On the left side, the 2x's will cancel out, and on the right, the 3y's will cancel out. So our next step will say 3y is greater than negative 2x plus 6. And to isolate y, we need to divide each side by 3. So our inequality solved for y is greater than negative 2/3 x plus 2. Now we want to graph the boundary line. Our boundary line for this inequality is y equals negative 2/3 x plus 2. The y-intercept of this line is at 0, 2. And to get a second point on the line, we can use the slope negative 2/3. We need to go down 2 and right 3. So here are 2 points on our boundary line. Since our inequality is greater than, we should use a dashed line for our boundary. So let's go ahead and connect these 2 points with a dashed line. Okay, now we need to test a point not on the boundary line to determine where to shade. An easy point to test is 0, 0. So let's take our original inequality. 2x, we want to see if that's greater than negative 3y plus 6. And we're substituting 0 in for x, and we're substituting 0 for y. Take some time right now on your own to determine whether this inequality, when simplified, is true or false. Simplify both sides and answer whether it's true or false. Choose A for true or B for false. And then I'll come back and help you finish the problem.
That's right.
Okay, you chose correctly. This inequality is false. Because when you simplify the 2 sides, you get 0 on the left and 6 on the right. 0 is greater than 6 is a false statement. So therefore, the ordered pair that we tested, 0, 0, is not a solution of the inequality 2x is greater than negative 3y plus 6. And that means we should not shade the region where the point 0, 0 lies. So we should shade the region above our boundary line. This region above the boundary line represents the solutions for our inequality. And that's how you graph a linear inequality. Remember, solve the inequality for y, graph the boundary line, and use a dashed line for greater than or less than, a solid line for less than or equal to or greater than or equal to, and then test a point not on the boundary line to determine which side to shade. If you follow those steps, I'm sure you'll do a great job. So, work well with graphing linear inequalities.
Hello, I'm Miss Adams, and I'm here to help with and show you how to use linear inequalities. So in order to do that, we're going to get involved and we're going to join the decorations committee. With a budget of $200 and table decorations at $2 per table and party favors at $1 per person, we're going to figure out some ways of spending that money. Now keep in mind there's a direct relationship between the money per table and the number of tables. That would be a multiplication relationship. Same thing with the money per person and the number of people. And we're going to combine those total expenses. And remember, we want to stay within a budget, so we have to be less than or equal to that budget amount of $200. So keep in mind the money per table is $2 and the money per person is $1. So let's go ahead and let X represent the number of tables. And let's let Y represent the number of people. And using that X and Y, we're going to write an inequality. So that tells us that $2 per table, so that's 2 times X, plus $1 per person, that's 1Y, less than or equal to 200. Now keep in mind, sometimes the easiest way of graphing a line is looking at the extremes or the intercepts. So that's when you might consider just spending money on the tables or just spending money on the people. So I'm going to go ahead and look at no people expense. And keep in mind when you're setting up that graph, you're going to look at it as a linear function first. So that means 2x is equal to 200 and x is 100. So if we spent all our money on the tables, we could set up 100 tables. We'll also take a look at when we don't spend any money on the tables and all the money on the people. We have 1y equals 200 or y equals 200, so that's all $200 being spent on the people. Now, if we connect that set of points, we get what's often referred to as a budget line.
Thank you.
Okay, and then we can consider points underneath the budget line. So let's say look at 25, 50. Okay, and we can see that 2 times x of 25 plus 1 times y being 50 is less than or equal to 200. That's 50 plus 50 less than or equal to 200. And that puts us within our budget. So we can take a look at anything that sits between the axes and that budget line as possible combinations of ways to spend that $200. Now, if you're outside the budget line, say we're at 175, and we go to look at how that compares to our inequality. We've got 2 times 100 plus 1 times 75, and again, if it's outside the budget line, it shouldn't be less than or equal to 200. And you can see right away, there's the 200. 75 puts us over, so it's not less than or equal to 200. It would be greater than that 200. Okay, so let's try another fun activity. So we're going to get involved and let's do community service. Now imagine you have some time slots to choose from. If you go to a daycare center, you can spend 2 hours there at a time. If you go do beach cleaning, you can spend 3 hours at a time. And if you need a total of 30 hours needed, we can consider the possible combinations. So keep in mind, with 2 hours at the daycare center, so let's let that X represent the trips to this daycare center. Let's let Y represent the trips to the beach. Okay, so what our equation is going to look like, 2 hours per trip, we're going to have 2x plus the beach cleaning, 3 hours per trip, 3y, and we need at least 30 hours. So that would be greater than or equal to 30. Again, we can consider the extremes. Let's suppose that we just go to the daycare center and no trips to the beach. And again, we're looking at fulfilling the 30 hours. So that would give us 15 trips to the daycare center. Okay, so we'll go ahead and put that point there as the x-intercept. Now we can take a look at no trips to the daycare center and all of our time spent at the beach. So that gives us 3y equals 30 and y equals 10. So our trips to the beach, if we do all of our community service hours with those, that would be 10. And there is our line that fulfills our community service. Now, if we happen to be under the line, we've got a small problem. You can clearly see 5 and 5, that's 10 hours, and 15 hours doesn't work. So what we have to make sure this time is that we stay on the outside of that particular line. And you'll notice something like, let's go with 2010. Okay, so 20 to the daycare, that's 2 hours for each time slot, plus 10 trips to the beach with 3 hours for each trip. That's 40 right there, and 30, that's 70 hours of community service, which is way beyond what we needed, but does a great service for the community. All right, so there's 2 good examples of how we can use those linear inequalities. Remember, you're going to graph the function first, then decide whether you are on one side or the other by picking a test point. Sometimes it's easy to see as you're thinking about your situation. So we know we need more. The bigger points are on this side. All right, you're all set to work with those linear inequalities. Give it a go. Hello, my name is Miss Adams, and I'm here to help with graphing absolute value inequalities. We're going to take the following steps in order to do that. First is to graph the V, which could be a solid V upside down or right side up, or a dotted V, same thing, right side up or upside down. Then we will choose a test point either inside or outside the V, and then we'll shade where the test point fits the inequality. So for instance, on this one, we would have an inequality where it is equal to in addition to greater than or less than, and we would have a test point that works on the outside. This one would not have an equal to because it's dotted, and then our test point would be on the inside. 0, 0 is a really good test point to pick because it's an easy one to substitute in. But it really doesn't matter which point you choose. All the points inside on this graph would have fit the original inequality. All right, let's go ahead and try some examples. So I'm going to take you through the first one here, where we have y is greater than or equal to the absolute value of 4x minus 8. Now keep in mind the following. When we go to look at what's inside, you're going to see the slope show up in the graph. The vertex is going to appear where this is equal to 0. So we're going to see where 4x minus 8 equals 0, and that would be at positive 2. So you can see the vertex at 2 and a distance of 0. Now notice again, slope would be 4. So one side of the graph will go up 4 and over 1. The other side will be a reflection, and it will have a slope down 4 and over 1, or the opposite slope of negative 4. Now we need a test point. 0, 0 is a really easy test point to pick, and we're going to substitute 0, 0 in for our x and our y. So we can take the y out, put a 0, take the x out and put a 0, and simplify. So we have 0 greater than or equal to the absolute value of 0 minus 8, or negative 8, and the absolute value of negative 8 is positive 8, and this is a false statement. 0 is not greater than or equal to 8, so this point doesn't work. So we want to shade not on the outside, but instead on the inside of that particular V shape. And if we'd chosen a point inside, that point would have fit the original inequality. All right, so let's have you go ahead and try this here. I've put in the vertex for you, and you can often use the opposite of this value and then this shifting down in the graph to pinpoint your vertex. All right, go ahead and try to put in your V and pick your test point to do your shading. Click on Continue when you've got your graph, and we'll come back and take a look at it. Okay, so remember we want points on either side of the vertex, so I'm going to choose a point of negative 2. Negative 2 plus 3 is 1. Absolute value of 1 is 1. Opposite of 1 is negative 1. Minus 2 is negative 3. And because of this negative, the V will be upside down. If I choose negative 4 and substitute in, I should see my symmetry, so the point will be down at the same level. So our graph would look something like this. Notice the slope of 1 on this side because of this, and the slope of negative 1 on the other side because of the reflection. Now let's pick a test point. Again, I keep coming to 0, 0 because it's the easiest. You don't have to choose 0, 0, but it's very easy to plug in. The time you would not want 0, 0 is if your V actually sat on that 0, 0. So maybe the vertex is there, or maybe the graph passes through 0, 0. So don't choose that point if it's on the V. So 0, 0 we're okay with, so we're going to put 0, 0 in for our x and our y. So let's take out the y, put a 0, take out the x, put a 0, and I have 0 less than the opposite of 0 plus 3 in our absolute value, which is 3 minus 2. So on the left side, 0. Is that less than? Absolute value of 3 is 3. Negative 3 minus 2 is negative 5. Again, I've chosen the wrong point because it's not satisfying my inequality. So this is the wrong side to shade on. And I happen to have another graph where the shading occurs inside the V. All right, you're all set to work on anything that involves graphing absolute value inequalities. Don't forget to graph your V. Think about a linear graph with a reflection. And then pick a test point. If the test point fails, you shade on the other side. So either outside if the test point would have worked on this one, but because it didn't, we shade inside. All right, you're all set with absolute value inequalities. Give it a go.
Hello, my name is Mr. Scott. I'll be helping you with writing absolute value inequalities. When looking at the graph of an absolute value inequality, the boundary is the equation y equals the absolute value of x minus h plus k, where the vertex is the ordered pair hk. If the boundary is solid, then use less than or equal to or greater than or equal to for your inequality. And if the boundary is dashed, then use less than or greater than. If the shading is above the boundary, you want to use greater than or equal to. And if the shading is below the boundary, use less than or equal to. Now let's use this information to work through an example problem together. We want to write an inequality for the graph that you see here. Let's bring our information down. And let's get started by determining the boundary of our graph. The vertex of the boundary is located at 3, 2. So the value of h is 3 and k is 2. Now remember, our boundary is the equation y equals the absolute value of x minus h plus k. Take some time right now to write the boundary for this graph using the values of h and k that we just stated above. When you think you have the correct equation for the boundary, hit the continue button to move on. Alright, welcome back. Hopefully you substituted 3 into the equation for h and 2 for k and wrote y equals the absolute value of x minus 3 plus 2. So this is the boundary for our graph. Now, taking a look at the boundary and where it's shaded, we can see that we have a solid boundary and it's shaded above the boundary. So we need to write a greater than or equal to inequality. And to write our inequality, we just replace the equals in our boundary equation with this inequality. And we get y is greater than or equal to the absolute value of x minus 3 plus 2. And we're all set. Now remember the steps. Determine the vertex of the boundary using the ordered pair hk for the vertex and substitute those values into y equals the absolute value of x minus h plus k. Then determine what inequality to use based on the type of boundary, either solid or dashed, and where the region is shaded, either above or below the boundary. If you follow this information, I'm sure you'll do a great job. And when you come across writing absolute value inequalities, work well.